Hello there, welcome to Weekend's Web App. This is day 14 and we are building a web app live on stream as we always do, and today we're going to be working on IndexedDB. We're going to be carrying it on. If you want to catch up to where we've developed up to, you'll want to use Git to check out day 13, because that's where we finished up last time. Get back on master, and we're pretty much going to get straight into it. So we've run up our server in the background here, and we've got the app running just here. And last time we set up some basic schema sort of elements. So, not schema sort of elements, but we started to build out our pages. So we had this concept of an author, and that author, you had to get the articles for that author. So that required us to have some sort of query, and we put that together. And then we just sort of started to hook everything together in the way that it needs to do. A bunch of different links back and forth. But we want to exercise our IndexedDB system a little bit more before we can consider it done. And then once we've done that exploration into that space, then we condense it all down. So I might run this stream a little bit longer because I won't be able to stream on Friday. Try just see how far we can go into cleaning up this system that we've developed for ourselves. Alrighty, I don't care about that. What am I doing there? So, if we look at the database, we've got the concept of saving and getting by key and querying and all that good stuff. And there are a few gaps in this system that we need to address before we can really consider this ready. Probably one of the simplest ones is the idea that saving we can't actually delete the database in this code here. And what we'd probably prefer to do is to be able to delete the database and then put that in a promise where we then delete the database and then put that in a promise so that we can just be constantly clobbering this database, getting rid of it, and that way we can test our systems rigorously, because down the track we don't want to have to manually delete the database every time something goes wrong. And eventually even down the track we'll have some sort of import-export system from the database so that we can cleanly bring in old and new data, so that will have some level of serialization. So we need to address a few things there. But baby steps first, and the main one will be to just make it so it's easier to delete that database. So let's do just that. So in my past libraries concept, you would have some sort of clobber sort of state, and that would sort of handle things. But I'm not going to do that. This time, I am going to simply go for something which deletes a DB, export a function like that. Yep, and we can put that down there after we're done. And it's going to delete a database of a particular name. And what we'll do is we'll return a promise from that function. So that way, anything that's waiting on the deletion of a database can know just to wait until that's done. So if you have a look at our documentation, I do pretty much remember it, but it always helps to check these things out. That way we make less of a fool of ourselves, and that way you can see where I'm getting all my information from, because it's important to understand that MDN is like, there's just way too much there, right? And you will remember bits and pieces of the spec, and like you'll have your familiarities and you'll have your specializations and whatnot. But the reality is you need to understand how far, like where to get your information from, so that you just don't run into problems. So yeah, that's what the documentation's for. So we need to find the API for just IndexedDB in general. I can't see where that is. Might be IDB environment or anything like that. Well, you know what? I can find it out just by running it here. So if we type down the bottom here, you got IndexedDB, and it's simply delete database. So that's going to be our first thing. So the request is going to be IndexedDB IDB. Yeah, we can use IndexedDB delete database. And that's going to be for the name there. And then after that, so if we were to look Let's just make a random name there, see what happens. So you've got that request, and you've got this ready state done, and you've got on success and on error. So what we would really be looking to do is just add an on success and an on error, and then go from there. So we can pretty much wrap all of this into a promise. So we'll wrap that in a promise, resolve and reject. I'm getting my syntax wrong. So wrap that in a promise, and then inside here, we're just going to add ourselves a request on error and a request on success. And we're pretty much going to do pretty much what's down here. It'll be a little bit different, but I might as well copy and paste it. It's not a big deal. All right. So we'll go for error, deleting database. And I'm pretty sure it doesn't even come back as an error when it's a failure, but I mean, we'll find that out in good time. So database deletion successful for this logging message. And I mean, we're not really going to return anything of great import. So I'm just going to resolve to true. It's really not a big deal what comes back in the resolution here, because the main thing that we care about is just whether it's done or not. Everything else is immaterial. So that delete DB gives us some sort of promise. So what that should allow us to do is, if we make a variable here for let DB, I'm going to do it like this just because I want to have a little bit of space between. Yeah, I just want to have a little bit of space so that, like, inside a promise, I can create that item without having to do something weird to pull it back out. It'll become clearer in a moment. Let me just follow it through. So database storage. Yep. Okay. So that's going to be there. So I should be able to say that this is going to be of type database storage.db. And then here, instead of doing this here, we're going to do it inside a promise after the deletion. So we'll start off with a database storage.deleteDB, and that's going to be www data. And then after that's successful, we don't care about the result, so we can just make it an empty function like that. After that, that's when we create our database. And then we return this promise. Remember, if you return a promise inside a promise, it'll just propagate out just as it needs to. So it'll be fairly predictable what happens as a result of that. Have I got the... is the end of that one. Yep. Okay, and then I just need to add one more then. And that will be that one there. Just indent to match. We could do this just to make it a little clearer that it leads on. So yeah, we have delete database. Doesn't like that. Okay, we might have to do something different. Why can't I get the type there? That's a bit annoying. I'm going to have to pass the type a bit further through so that I can actually do that. I'm just going to appease the type gods here. So persistence index is, I think, what I'm looking for. Yeah. Okay. I'm just going to export const, export DB. Let me do it. Yeah, that's what I can do. So rather than exporting it as part of the default, I can export it down here. Type system will let me do that. Yes, it will. And then I'll grab DB out of this. And just let it out there. So that should give me access to DB now. If I pull it from platform persistence. Right, everything's done there. All right, let's see if that works for us. So database deletion successful, database upgrading because it's coming from 0 to 1, added the stores, added the index, then chucked in all our items. Actually, this is the query. So yeah, database is ready. It chucked in all the items in between there, and then we were good to go. All right, so this is good, but we want to do more with this data as well. And this is where it gets, well, not tricky, but it starts to build out our concept of what this is all about. So if we look at articles, I don't want to go crazy with this. No, I don't want to go. I don't want to go overboard with this. But what we do need to do is possibly just give us some room for a bit more complexity in what we're doing. So what I'm going to look into is adding a field for publication date. And that's going to be a string. And I'm going to tell you why. Even though we're not going to talk about localization or date work or anything like that because it's a complicated subject and I don't want to mix it up too much with what we're doing here. When we handle dates on the front end, like there are a lot of libraries for making particular items and stuff like that, but there is a singular standard serialization format that we're going to be leaning on very heavily when it comes to dates, and that is the ISO standard 6901, I believe. Maybe I got the number wrong. ISO date 8601. Yeah, well, I don't know where I got 6901 from anyway. So 8601 applies to representations and formats of the Gregorian calendar. So the ones that you're probably familiar with, right? These ones just here. So there are a couple of good reasons why this is a good serialization format. First of all, it's a standard, which means pretty much everything supports it. And second of all, because it's immutable, because it's a string, you generally don't end up with weird things happening to that string while it's in transit from one place to another, as opposed to the JavaScript date objects. Yeah, they're not fun to work with, and we probably won't be working with them. We'll probably just use a library because that's one of those cases. When it comes to date times and stuff like that, it pays not to mess around with that sort of stuff. But nonetheless, we still need a means to get information, into IndexedDB, all like moving it around from the server, all that sort of stuff. And I like this standard string is going to be the thing. So essentially, it's the year, then the month, and then the day. And the benefit of this is it actually alphabetically sorts as well. So you can definitely know that if something is earlier than, it will like the alphabetical sort will work out based on numerical order, which makes it very handy, especially when you're using it for IndexedDB, because it means that those key ranges. So remember those like the indexes, the key ranges, they work out as well because of that alphabetical sort. So that is exactly what we're going to be using to express our dates. When we bring dates into this, I want to avoid having too much sort of crunching or anything like that. And I also want a lot more entries than what I've got right now. So what we're going to do is probably just build out a range. Yeah, we'll work through this and we'll squeeze out like 40 entries or something like that. So we're going to make ourselves a for loop. So make an index number, so index equals 0. While the index is less than 40, we'll keep going. And then every time we come around, the index is going to increment. So we're going to make a const called articles, which is going to be an array of this interface of articles, just like that. And then finally, we're going to export default articles. All right, now that means that these are at loggerheads, but that gives us a chance to now work through this concept. Alrighty, so if we were to take this as it is, I'm probably gonna get rid of the literal 1 and the 2. I don't want to worry about translating these to words or anything like that. So what we're going to do is look at articles and keep on pushing on our articles. And each time it's going to have an ID, which is going to be entry plus IX. And then if we keep going, we'll have our author ID. And this one, well, we may as well do this randomly, kind of randomly. JSON random isn't great. We've got math.random that we can use. That'll do for now. It's not cryptographically secure, but that's not a big deal in the case that I'm using it. So what we'll do is we'll do math_random times 4 to give us a number. Actually, no, math_random times 3. And that'll give us a number between 0 and 3. Actually, we've only got 2 authors, so let's make that math_random times 2. And, oh no, we can make it 3. Make it 2. And we will just round it. So it will be either 0, 1, or 2. And that'll probably distribute in some weird and wonderful ways, but that's not a big deal. So onst author ID will equal math.random times 2, and then math.round. So that should be fine, because that will give us either 0, 1, or 2, and then we put it to a string, and we should have ourselves an author ID. Now we still don't have enough. We need our title, and that's going to be IX plus dot entry, and I might actually do template strings for this because it'll look a bit nicer. We'll do that up here as well. Okay, and then the content. We'll make that Limson. We need our publication date as well, and we'll just make one, but we will expand upon this real soon, because we do want to have some sort of a range of that. Okay, well, let's just try that, see what happens. All right, so we got our entries. They're not 0 padded, but I mean, I'm not super worried about that. That lack of 0 padding is why when they alphabetically sort like that, they end up like this, is because technically all the first entries, the 0, 0 should be 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, and so forth. So that alphabetical sort is not super right, but it's not a big deal. But you can still see that all of our data structures are still maintained here. We've just got publication date in there as well. Now with that publication date, we don't want it to be just this. So what I'm thinking is that we will step the month down every time, and then step the year. So each of these articles will have a month between them. And this is just so that we can start to exercise our concept of queries a little bit more. So we'll go for year 2018, current year argument, and month equals 6. Yeah, 6. This is going to be funny. Like, I'm not even going to bother with the 0 padding. What I'm going to do is I'm just going to keep on rocking through this and see how we go. So, like, I just don't want to deal with anything that refers to doing dates properly or anything like that right now. So we're even going to ignore the months 10, 11, and 12 in this case. So we'll start with month 9. Alright, so we've got a 0 there, and then we put the month. And then we will always have it in the middle of the month, like 10, 15, or roughly in the middle of the month. Okay, and every time we do this, we're going to do a month decrement. So we just take month away. Now, if month equals 0, which means we're all the way down, we've run out of months, then that means we can reset month to 9 and we can decrement the year. Alright, so if I jump to home now, I mean, this has got the database deleting every time, so we should be able to depend on this sort of behaving every time we do this work. So let's see if we can just render out that that publication date in, where am I here? In this render here. So we'll just go article dot publication date. And the interesting thing about this is, like, if we use this as a sort, then this probably makes our this will make it a lot easier for us to get that order that we wanted again. So let's do that. Let's sort by publication date and prove that whole thing I said before, where if you make the publication date, like if you use the ISO standard, you've got things in order. So at the moment it's going in the ascending order, so starting from the lower state. If we wanted to reverse that, what we could do is simply compare B with A instead, and that'll end up with those happening in reverse, because the result of the locale compare will be the reverse for the sort. You can also, an alternative to doing that is, because these sorts are based on maths, so this sort is based on it returning 1, 0, or 1. Because of that, you can simply multiply it by -1, and that will also reverse the sort. You can see that here. So now we've got entry 0 all the way to entry 39, and you can see that they've got a distribution of different authors and all of that sort of good stuff, and we can go in and we can see who's responsible for what if we jump into their author page as well. So that's all gravy, that's all good. Now, what if we were to do, say, something like we wanted to pick a slice of, we wanted to make sure that all of them were in recent times. Say, we'll fix the date and that kind of thing, so we're not really doing any proper date knowledge. But let's say we only wanted to show the new stuff on this front page, right? Well, we could filter here. That's absolutely true. But say we didn't want to do that. Say we wanted to make this this instead to be a query based on date. Well, let's see whether we're actually able to do that with our current technology. So we've got the ability to create a query just here. And we can pop that up here. And what were we looking for? We're looking for publication date. And this is probably this is going to be an issue straight up the bat, because I don't actually have an index on that one. But let's just follow this through, get the bug out, and then we'll go from there. So let's say we want everything to be greater than 2017 0101. So everything after the start of the year of 2017 is going to end up in this filter. And so instead of doing a get all for articles, we're going to do a query for the articles. Call it query. And we'll name that query recent articles query. Oopsie daisy. Cool. So if we do that and we're on the home page, Okay, failed to execute index on IDB object store. So I did say that would happen. So let's deal with that. So if we go on to app.ts, and obviously we'll pull this schema out eventually, but for now, we're just sort of happy to exercise things and keep it going. So we need to add an index on articles for publication date. Okay, so you can see that we have the ability to do that. Provided the index is in place, we have the ability to do that, which is all good, right? But what if we wanted to do that same logic for our author page? We wanted to limit them just to their recent stuff. We only want their new stuff. Or maybe we only want their old stuff. Yeah, we only want their old stuff because they stopped being cool after around 2017, right? So we want everything less than 2017, say. So in order to do that, if we're going to run a query on that, then we need to run through this filter. Same deal as before. And then instead of doing the lookup in... So we need this author equals lookup, but then we also need to look up against publication date. And we're going to go for less than, and then the start of 2017. Okay. So if we do that, and we jump into James Rackich, reload, and we'll have to fix up his... who is that guy? We're going to have to fix up publication date here, so we'll chuck it in here. So article.publication date right here. Chuck that in. Reload. Okay. And you can see we have articles from 2014. And you've also got, because these have still got the old sort of a title, let's fix that up. We'll make that sort by publication date as well. And we'll time it by -1 to make it the descending sort that we want. Yep, so you got 2018 going down. And you'll see that the query pulled everything, right? And this is where IndexedDB as a query language, I mean, it doesn't really have a lot of source, right? It doesn't get it done for you. It got all the entries for James Rackich, but it didn't do anything more than that. And that's where we do need to start to look into how we're going to handle additional filters, additional additional parts of your query. So if we jump into database and jump into query here, you can certainly see that we've got some basic concepts here in terms of yeah, the query runs, right? We do know that, okay? But there is a point where we don't know what to do with the remaining filters. So we need to turn everything that's not part of this cursor into essentially a JavaScript filter, right? So if there's not a key range, then that means every single filter if there's not a key range, then that means every single filter has to be handled by JavaScript. All right. So if we've got say JS filter equals, actually we'll do let JS filters rather, and those JS filters will have a type of key definition. Hang on, what am I doing? Filter definition. I might not have that type in here yet, so I'll have to grab that. Yeah, I've got query definition, but not filter definition. But yeah, if we grab that from query and make use of that type. So we've got JS filters, filter definition. If we didn't get a key range, then that means everything has to be done by JavaScript rather than by using the key range feature. So in this case, JS filters would be equal to, what is the name of my variable here? Query definition. Yeah. So query definition dot filters. Oh, and it needs to be an array there. Yep. And the alternative, if we did find at least one key range, that's gonna like improve our performance, but we still need to do the remaining things. And we can do that with a slice function. I'm pretty sure I've used it before, but just to remind people, the slice function slices bits. So we can slice the first item off the array by using slice one, and that's right what we're doing here. So with this JS filter, we can continue to test whether this item passes through the gauntlet, right? And we need to understand what we're looking for here. We're looking for something where everything returns true when it goes through that filter. If everything returns true, then we are allowed to push it. Now, this does mean that we just have to make sure of an implementation detail. Well, not an implementation deal, but part of the spec. Like what happens with the array function that we'd use. So let me just take a quick look. So we would be looking for every. So returns true if every element satisfies the test. But what if it's empty? What happens if it's empty? In particular, for an empty array, it returns true. So yeah, it is vacuously true for any of the elements of that empty set. So that's helpful for us. What that means is if there are no filters at all and it matched the key range, then we are good to go. Because every... we need a blah test in here. So even if every time it would return false, that will still be true. So empty arrays are true, which is good. It means that match query could be done by going over all the JS filters, running some sort of function with them, using every. And then we got to do something in here. So we just return true, it would just work. Okay, we could test this. So matched query results.push cursor value. Otherwise it carries on, right? So this would give us our items. Or alternatively, we could go return false and it wouldn't give us our items. But now we need to actually, figure out what that is there. And we'll remove this to do because we're in the process of doing it. I'm going to jump over to query now because this logic is not something that I want sort of in this this larger library. And eventually we'll sort of tear it apart and clean it up and whatnot. But we need to follow this through a bit further before I'm comfortable doing that. So we need to export a function which is essentially apply a filter, apply a JavaScript filter. And it's going to take a filter definition for sure. And it's going to need to have either the value or the object. And I'm kind of inclined just to make it the object. Yeah, so we'll just go obj, and that'll be any. Yeah, I'm inclined to do the object because the definition does have the key in it. So we should be able to do the lookup based on that. And then, yeah, if we've got that, then we should be able to do our tests. Just like all of these guys, we'll sort them out and work our way through it. So, and this finally will return a Boolean. And unfortunately it doesn't currently work. We'll just return false to start off with. And we'll drag it into here. So that's apply JavaScript filter. And right here where we've got the return true, we're going to change this to be apply JavaScript filter. And we've got filter and then the object, which is cursor.value. And that has to be any. So with that, we just need to now work through all of these and figure out whether they're the right way around. So So because of the concept of exclude, what we're going to do is have a concept of match. Yeah, we'll have a concept of matched, and we'll have to work through that. So we'll start off with false here. Default to false, and finally we return matched at the end. And we'll handle the exclude later. For now, what we'll do is we'll work through all of these different concepts. So if def.lookup equals, what do? Well, we need to check if def.key, so if that is equal to the term. So if def.value. That's what we're looking for. And we can go matched equals that equality, right? So that's number one. All right, what's number two? Greater than, equal, etc. Let's go through all of these. Okay, so the greater one's kind of tricky because we potentially need to know the type. And I'm going to ruminate on that just for a little bit because we might have to introduce Schema real soon to actually do that properly. What I might do, I just have to take a quick break. I'll have a think on that. You should probably have a think on that too. Is at this point, we need to sort of start to handle different things. So here's what's giving me pause, right? Because sometimes we're going to have this and say this, right? But see, this kind of thing actually like coerces to numbers. It's not great. So sometimes we're just going to have to handle different types, and sometimes they're going to be numbers, and sometimes they're going to be letters and all that. We need to handle all of these different cases. So that's what we need to think on briefly. But I'm gonna pause for just a moment, and I'll be right back. Alrighty, so we're sort of avoiding having to do schemas just yet. So, because what it might mean is this comparison based on whether the key was, like, whether you're expecting a number to be there or whether you're expecting the string to be there, that would change what your comparison logic would be. But maybe we don't have to do that. Maybe we can just go for essentially all of these cases. So for greater than, less than, actually we're doing or here. So for all of these cases, we want to drill down the values so that they sort of match, and then we'll go from there. Or at least figure out which comparison to do based on having the right, doing a different comparison based on the type of these. And we can do that with a very sort of a native JavaScript thing called type of. So we can get the type of def.value, or actually we can get obj value. We can get that from obj def.key. So we can get that value, and then if type of def value equals a number, we'll do one thing. Or maybe we'll do the string, and then we'll just use a numeric comparison for literally everything else. So here, we return obj value greater than, like we can use greater than, less than, etc. And for here, we will use locale compare, because weird things happen when you compare strings. Allow me to demonstrate. So this one here, one, well that is true. But see, you can start to throw these things in. These strings can sort of muddy up the waters, right? And the reason why the strings can muddy up the waters is because JavaScript does a bunch of conversion. And honestly, I don't remember all the rules. And the reason why I don't remember all the rules is because I'm at a point where I've transcended beyond that and just never want to deal with that, which is why I use TypeScript. And just JavaScript can do weird things if you just use greater than or less than. So it's always better to do locale compare and get your information that way. Because that way, locale compare, it's guaranteed to be a string comparison. Very specifically, a string comparison. So here we can go, so we can get the comparison. We can take obj.value and then locale compare it to def.value. And when we do that, then we need to interpret that comparison the right way. And I'll probably flip these numbers and get it wrong. So we'll have to play with this and get it right. In fact, let's do it right here. So if A is .locale compare B, so if that's the value and it's the B, then that means if we were to do a greater than B, how do we interpret this? Actually, let's just use numbers because I will make less mistakes that way. So if we do locale compare there, we've got one. Okay, yeah. So if I like greater than the term value would be a positive number. So here we can, so if comparison greater than 0 and def.lookup equals greater than or greater than equals, then we are matched. comparison. There we go. Or def.lookup equals GTE. This, I'm just going to make it really clear that these are independent to this one. So it's this and this condition. So if those match, then we are matched equals true. Now if else, if comparison is less than 0 and def.lookup equals less than, or def.lookup equals less than equals, then we are also matched. And finally, else if comparison equals 0, then that means they were equal. And that means that we can accept if the lookup is less than equal or def.lookup greater than equal. We can also say match true. So that handles our string comparison, and then everything else is just going to use the greater than operator. So simply put, we're going to work through all of these operators. This def.lookup equals GT, and that means it's greater than. So here we're going, it needs to, so return, so rather matched equals obj value greater than term. Hang on, am I thinking it the right way? Yeah, no, that's right. Okay, yep, so obj value is greater than def.value. And then we're just gonna work through the whole lot again. We could have done this with a switch, like, who cares? I don't know, like, it doesn't make that much of a difference really. At least not in the way that I'm using it, so just gonna keep on charging along. Join that there. Oop. So now we've got less than equals. It's cool that because that's picking up that it can't possibly get through to that point because this point has got exactly the same comparison. Anyway, greater than equal and less than equal. That way? Yeah. Okay. So that's pretty much everything we need. And then finally, we need some way to flip the script down the bottom in case of excluding, right? And we will test that out. We'll test that out really briefly. So if exclude, so yeah, if def.exclude rather, then we will return not matched. Otherwise, we'll return matched. And for this kind of an if-else clause, I mean, we can just use a ternary statement. So I don't know if we've even done. Well, we've never drawn attention to it if we have done it. So if def exclude, then we return not matched. Otherwise, we just return matched. And that saves the need for that that if-else statement. Makes it an expression instead. Okay. So if we do this and now run it, well, now we have a query. And you can see here, it only picked up the stuff that was before 2007 to 2017. We're just sort of going to have to trust that there's not actually a... oh, well, I mean, we can see it here, right? So we can see... Yeah, there was only 5 articles and all of them were by James Rackage and they were all before this time, right? Now, unfortunately, because we're not actually doing the query in our code as well, you can see that those items are there now. But I mean, it's not a big deal. It is what it is, and we're really talking it like because it's in the store. Because once it gets put in the store, we'd do some code to handle that case. And in this case, we're not. But that's not a big deal because our focus is on the IndexedDB system right now. Well, let's test if our exclude code is correct. And do remember, we're actually like exclude will also test the exclude will also test the concept of using the using no key range at all, because there is no such thing as an exclude key range. So we will actually have everything being JavaScript filters in that case. So let's give it a try. We want to go to app.ts. And up here, this query. Okay, so we will... Okay, yeah, no, if we made this one, it would be an exclude. Let's just start with the JavaScript exclude. So we'll make that an exclude, and this should be flipped. So now we should only get stuff that it's actually higher than 2017. And you can see that's right what we've got. Okay, so that's exclude working there. Now, what if we were to exclude based on article? So now what will, on author rather, that would test everything being run through this same filter. So let's try that, hey? Okay, it failed, it broke. Why did it break? Oh, of course, because it excluded and picked everything up, but then of course, because this runs a filter, it's yeah, because this actually filters here. That's just what ends up happening. What if we get rid of that filter, right? Cannot read property full name of undefined. Yeah, so it hasn't actually got the authors there. It's missing information, so it ends up screwing everything up. But that's cool. Like I know that the query worked because I can see it right here, and it's all got author 1, 1, 1, 1, 1, 2, etc., etc. You can see all of those entries there, so I'm satisfied that that works. I don't need to investigate that further. We will eventually test all this, but not right now because we're still in investigation and whatnot. Okie dokie. Well, this gives us some stuff to work with. This is cool. So where do we go from here? Possibly time to think about that schema, I think. And the thing about a schema is like, yeah, we've got our type system, but a schema is going to give us more to work with when it comes to, say, relations and that kind of thing. And I'm not particularly inclined to start building out relationship functionality where it's like automatically going to get, say, the author for the article and that kind of thing, because our logic is not really complicated enough for us to need to do that. And by keeping it simple, I can make it easy to debug. I don't have to like go into too much detail with any of this. I can just work through the concept. So I'm sort of happy with where it is right now. I'm even going to comment this out now that we've proven that it works, at least for the basics there. Oh, did that actually pick up? Or is it just having trouble? Oh, no, there we go. Yeah, we've got 2018, so that's all good. It's just getting a lot less entries than usual on those builds there. That's okay. Although it's interesting here, do we still have a filter up on the home? Yeah, so we have a recent queries article. Now let's just for human's sake, let's say we've got an empty filter. It implicitly has an any type. Oh, that's unfortunate. Well, if it's a query definition though, yeah, let's just go with that any type. See if it empties. Cannot really read exclude of null. So that is a problem. I would like empty queries to work, even though, I mean, technically it's wrong. Like you're not using it right, duh. But there's no real need to do it. So if not key range, so we can actually skip over this one. So if we have an initial filter, we can use that ternary construct. I actually quite like this pattern. There are a lot of people who don't, but I'm I'm kind of partial to it. It works. It's a fairly easy way to do this simple if-else statements. You know, they're basic expressions. We know that based on initial filter, we will either do this or we'll put null in there. And by using that information, we can propagate it down to there. We don't have to create yet another if-else tree to facilitate it. So I kind of like ternaries for this sort of stuff. And if we do that, now that empty query will get respected, right? It's got no filters, so it literally just smashes on through, does its thing. Works for me. So I think we're at a point where it would make sense for us to do some sort of a commit. And I'll just change some things around, because even though that, like, I'm kind of happy with that being a type error. And we'll grab all the articles here. Get rid of the recent articles query. Still got things that working. Yeah, cool. And eventually we will do more complicated things with IndexedDB. But I don't want to just, I don't want to make this into like, because we've already spent 5 streams on IndexedDB now, 5 days, quote unquote. So I think it's time to put a fork in it. It's done. And we need to just we need to tidy things up and get some sort of schema concept in place, I think. So what are we on? We're on day 14. Implement schema. Sorry, not schema. Implement JavaScript query filters. Handling strings and number types. For IndexedDB. And yeah, it's long, but I don't care. Alright. Where do we go from here? As I said, I'm sort of happy to run this one a little bit later, just to do some cleanup. So I think it's a good time now to start to look at our API. Not necessarily objectively, but from the bird's eye, and then we'll go from there. So this concept of a DB, in fact, we'll go to database storage index to start off with. So we have an initialize DB and a delete DB concept. Happy with that? That works for me. We don't do any error checking. So potentially we can really mess up our database if we're not careful. And I'd like to avoid that. And I think the way you do that is by having a schema. Because as nice as it is to just stuff in a barrel and just say, oh, yep, she's good, truck it, keep on trucking. It's even better if you can depend on your data, because the reality of this data is if we have a customer using this app and we want them to trust us, we need to show them that, their data is important to us. And, the markers for trust are obviously different for an end user. But if we don't do our due diligence, that might end up with us having to really sort of explain ourselves in a point where there is no way for us to recover the data. So I think it's really important that we have some sort of a schema that guarantees that the data that's going in does match some sort of shape that it's meant to be, right? And we probably won't go the full 9 yards with this, but we will at least start the process. We'll say, all right, these are the things that have indexes. These are the things that, these are the way migrations should work. We probably won't go that far. Let's just do basic schema to start off with, and then we'll go from there at a later date. Because as I said, I don't want to just sit on persistence forever, because this is still it's still a prototyping layer, right? It's not going to be something that we ship with. But if we don't get to actually writing the code for the main app, we're not going to actually encounter the problems that we need. So we do need to keep on working towards that. So if we jump into database storage and have a concept of a schema. So this schema is just going to be a series of interfaces again, I believe. So we're going to have a store. We'll call it a store schema. And that store schema, it'll have a name, which will have a string. And in addition to that name, it will also have fields. And I guess we can do something like it has a key string. And then we have a field schema. So we'll have an interface called field schema. That's what we'll do there. Okay, so what are these fields? Now, let's again look at the kind of things that indexes can do, because that's really what constrains us here. I mean, we can create date time types and all of the, we can go hog wild with all that stuff, but it doesn't matter to IndexedDB. It doesn't have any concept of types beyond simple JavaScript objects. Like if we take a look at what's in the store, it is a literal JavaScript object, right? It has strings as keys, and as strings, it has potential numbers there, but it doesn't for this one. But if we look at the articles, again, it's all strings, right? Or it could be objects inside there or whatever. What we really care about is what the indexes are. What are legit fields within this space that we can run queries on, and stuff like that. Like, if there's anything that doesn't have an index, we need to know about that. So we need to know if it's indexed. We need to know if it's multipath. Because if it's multipath, then that means that we can test against it in various ways. And then we've got a type, and we'll go for value type, hey? And that will be an enumeration. So we'll make an enumeration, and we're going to have to export all of this. So let's do just that. So we're going to export an enum, and what are we going to call it? Hell, I don't do enums enough in TypeScript. So how do you do enums? Give me the syntax. Oh yeah, there it is. Okie dokie. So we want an enum, and what's this enum going to be? Value type. We can just call it field type. Most of the time it's going to be fairly local, so we can use type here. I think this is a time where we're justified to use the word type. Okay, so let's see what we have. We have a string. Possibly not the best use of that kind of an enum, but anyway. It's scoped, so it'll be fine. All right, what else we got? We've got a number. Again, it's going to match the class name. Good for you. All right. Well, we might care about dates eventually. So let's say that date is one. This is also, like, I'm literally just listing out all the JavaScript types because that's what it is. So, like, we've got a date type. We might have a date. We don't have a date time type. So we'll be safe with that one. So date time will be an object, a string, but it will have more information because it will be an ISO string, and that's what we may eventually validate against. And it will have sort of 24 hours, sort of all the way down to hours, minutes, seconds, and then milliseconds, and then a time zone, or Z, which is for Zulu, which is Universal Time Coordinated or Greenwich Mean Time. Either or, take your pick. It's UTC now though, if you really want to be current year argument. Now let's see, what else? So the other thing that could be in there is just a straight up object. And again, object. Oh, wait, whoops. What am I doing? So while all of these items here have all been sort of base level things, keep in mind that we, IndexedDB can look like anything, right? So we could have, the ID here, which has a string, which is a string, like collection of numbers, letters, whatever. And then we could have like a big bag of JSON. And this could look literally like whatever. And most of the time we wouldn't query against that sort of thing. Cannot find name. That calms it down. So most of the time, there will be some sort of fields where it makes sense to just put in JSON because there's a bit of complexity. But the thing to understand with those is that we're not going to be able to query against them in any way. The only thing that we can query against is an array that has multipath. I don't even know if I want to do that. Yeah. So with an array that has multipath, and realistically the field type for them is actually going to be something like string or number in that case. And we're sort of asserting that it's this type or this type and not actually an array type. So these are sort of our flexible objects for when we want to just chuck things into the store and we don't want to think about it too much, and it's most likely not going to be indexed. So typically not indexed. There's no point, right? And same goes for this one here. But the interesting thing about it is because we do have those JavaScript tests, remember these tests right here, potentially we could have a filtered definition for a custom function where you're just able to like throw in your own function that checks out this item and figures out whether it's legit or not, and that could be pretty useful, right? So like just because they're not indexed doesn't mean they couldn't be searched over. So that's just something to keep in mind. That could be part of our schema, right? So I think that's literally everything that we would need to have some sort of a schema. And I'm not going to do too much with this just yet. I'm not going to do any validation on it or anything like that. But I still want the schema there, right? I want the idea of the schema in place so that we can start to build from it and understand what it can get us. And that's actually like that's probably a really important thing to keep in mind, is that like this doesn't help us unless we figure out what the schema is for, right? Like what it particularly is doing, where are the points that it needs to do its validation, and that's something that we will learn by doing. I mean, like obviously I've got some ideas, I've got some opinions, I've got some ideas about where it's going to go, but I don't want to rush headlong into that because that's not going to necessarily make this whole process make any more sense, right? So we're gonna, for the DB schema, we're gonna have a name. Maybe, yeah, we could bundle in the migrations with it as well. Probably makes sense to. It would make sense to, yeah. Let's put the migrations in there as well. So if we import, what's it called? Inside migration. Yeah, so if we import migration from, oh, I shouldn't have done that. If we import migration from that, and then we'll have migrations, an array of migrations. Oh, I don't need the comma. Wait. And then we need fields. Stores. It's kind of funny because I mean I could make a list of stores. It's neither here nor there really. But it is going to be easier for accessing them's sake down the track if I make it key value. Because eventually we will want to define some sort of relationships like, this is related to this. How does that relation look? And like it might be worth just talking about that briefly as well, since we're running this stream a little longer. So say if we've got stores and the store schema right here, what we've probably got is a concept of relationships here. So if we were to export an interface for our relationship schema, And literally all that's there for is to help the database know what to do in the case of preloads and stuff like that, which we haven't configured yet, and I don't really want to go down that road just yet. But let's just say that we have some field so we have a field name for the relationship, and then the store name for the relationship, and then finally a store key string. So what that does is, so we would have something like, I'll define the relationship and that'll hopefully make sense. So we've got stores, we've got fields, and then we've got relationships. We'll just call it relations, not really relationships. We'll call it relationships. I like the word. All right, and we're going to do the same thing here. We're going to have a relationship schema, and we can just fold that in like that. So that is our schema, and what we will do with our we'll get past this, and we'll have the database. So when we initialize database, so that comes from database storage index.ts. So here, instead of providing this, we are going to provide a schema. So import schema, database schema. What do we call it? Oh, we literally called it DB schema. I'm cool with that. All right, and what else do we need? We need to provide the field types as well from schema. So we will provide this now. And instead of migrations coming from that, migrations are going to come from schema.migrations. And then we do the slice. That's migrations to apply. And here, down here, we've got database ready. If we add the schema to that, then we're good to rock and roll. We'll chuck that into dbts. So now if we grab schema, db schema rather, from schema, and this will down the track allow us to do things with that schema, and we'll make it public because I mean it's going to be a public thing. It's not that this really holds much water. Like it just like TypeScript will tell you off if you try to do something with it and you're not the DB class. But realistically, like it's JavaScript, there are no rules. Only continuing Magnus. Anyway, so once we provide that schema, we now need to update our app.ts because everything will be broken, as you can see. So we need to fix that. So let's do just that. So what's our schema going to look like? Well, it's going to look like that, but it's not of the right shape. So what do we need? We need a name. Looks like we got some duplication there. Maybe we don't even need this right here. Gold. All right. So we can get rid of that name. And instead, we're going for schema.name. Is name used anywhere else? Delete DB, it's used, but we don't actually need the schema for deleting a database. So I'm still fine with that. We need to provide the migrations. And we are now missing our schema. So what does our schema look like? I literally only made the interface and have forgotten its shape. So let's deal with that. So it has a series of stores, has a name. Oh wait, no. So it doesn't have migration, it has stores. Here we go. Right. I understand what I'm doing now. So we would have authors as one. And we would have articles as one. And I'm still not doing enough work because I don't have the inside of this sorted. Got to have a name, which is a duplication, I will concede, but I'm not too phased about that one. And now we get into the fields. Actually, we'll do both of them. We'll just get the type checker to stop complaining, and then we'll finish the for. All right, so the type checker is done complaining, and what we're going to do now is just add some of those fields in there so we know what indexes we've got. Right, ID. So that is the string. Type. Yeah, this is where we do use type for this one. Yep. So it's indexed. We know that to be true. Rather than being explicit about multipath and indexed, I will instead make these optional. So the only one that you literally have to provide is type, although you will constantly be providing indexed. And that just comes with the territory. I'm going to have to grab field type out of this. Where do I get migrations? Oh, const add store, database storage. Oh, we can do that. All right, I didn't realize. Oh, of course, because it's the enumeration, so we can do that. All right, let me just grab that on index.ts. So here we've got field type. We need to export that here as well. And because of how generic the names are of those, I'm not going to destructure it like I have with other things. I'm just going to use field type directly. Huh, does it initialize data not? All right, it's complaining because I've completely ruined all this. That's all good then. So const field type. Yeah, we're going to pull field type off of database storage, which we can do. Yep. And then we're going to work through this. So field type dot string. And that makes the ID. Okay, what's next? So we look up at our schema because it's pretty much directly related to that. Authors. That is actually the full extent of it. If we wanted to talk about the other things that are in our authors structure, that would be a full name, but it is not indexed. So that is our structure. And there is a relationship. So that would be actually. Yeah, so how do the, like, there's many types of relationships, and potentially I've sort of jumped the gun on putting this sort of thing in because there's a foreign key relationship, which is where that's how the articles are related to the authors, because these articles have a key like author ID in them, and that points to the author. This relationship is a many to one relationship, depending on where you look at it from, because this has many articles. And like if you look at sort of Rails, like they all have slightly different syntaxes about this. I'm going to use Ecto as an example because it's probably the one that I've been sort of building out schemas with recently, that sort of uses this belongs to sort of sort of naming. So you've got has many, has one. So yeah, has many is not a bad name for this sort of a relationship. So let's export the enum of relationship type as well, because we do need that. And we will just use these names for now. So we have belongs to, has many, has one. Many to many is something we can do. Yeah, it's something we can do. Take a bit of nous. But with multipath, with keypath, we can probably handle that one as well. So, like we can probably handle all of these cases. So yeah, let's just put them all in, and we'll go from there. Come on, all right. And many to many. And the thing I guess to understand about this is, like, we can't enforce this. It's not like it's not like there's any sort of concept of constraints like there would be with a SQL database. Just because we say this is something we have to enforce by making sure that the data that goes in isn't right. And it's really just a marker that means hopefully we'll be able to save ourselves from some big mistakes potentially. And it also, like, this is also a method of communication to future me once I've built this out. Because again, do keep in mind that if we mess this up, if we push an update that sort of does a migration or does something wrong with the code, we could potentially pollute like hundreds of users' data and have no recourse, have no way to do the work ourselves because the data is on their device, right? How do we fix that? Well, I mean, you could do some stuff where you export all of their databases and then try to figure out the right steps to fix it all up. But I mean, that's a headache we really don't want to get down. So in terms of data management, preventative steps is always the better way to go if you can. Right, anyway, let's grab that. We need to take the relationship type and provide that enum. Yeah, we need to provide that enum down here. So that we can use it in our schema. So let's just do that. Right. Okay, and now we're back to simply just defining our relationships here. So we can provide an has many relationship. Actually, we won't do it like that. So it'll be based on ID. Yeah, see, it's a weird one here. This one, like, the names do actually count, right? So we want articles. This is the relationship called articles, and it has field type. It is of type, oh, we haven't even put the type on there. Relationship type, it's better. Okay. So we've got a type of relationship type dot has many articles. The words work. And the field name is going to be ID. Yeah, that's what we want to do. We want this key, then the store key, and then the store name. And that's going to be sort of our link between these two. So store name is going to be articles, and store key is going to be author ID. That defines that relationship. Okay, so now we can jump into the fields for the article. we've got ID, again, indexed. We've got author ID. That is an indexed field. All good. We've got title. And we'll index that. Sure, why not? And we have indexed that. And we've also got publication date. And this is our much vaunted field type of field type dot date. We don't do anything with that information, but maybe we will one day. And we also have content, and this is not indexed, so we can leave that blank, and we just go type field type string, because that's exactly what it is. Okay, and we do have a relationship, so that would be a belongs to relationship for author. So we have an author type, and the type is relationship type dot belongs to, because an article belongs to a singular author, one. And the field name is on this side, it's author ID, and then the store name is authors. And then store key is its ID. I'm not in love with the name. Store name, store key, field name. Potentially that naming can be a bit better. I don't want to overthink that though right now, because I think that'll just get in the way. This is the basics we need for an IndexedDB setup. And what will eventually happen is we will probably do some sort of validation against this. We will make sure, for instance, that the migrations, when they take place, they will result in that store. And I'll see if it's still in my browser history. Yeah, it's still there. So we used to do that for the concept of JohoDB, which is that old library that I made that used web SQL as one of its layers. And when it did it, it would essentially, it would warn you if you needed a migration, even tell you all the migrations. It was kind of handy like that. So it would has that vernacular of add table, add column, and it would essentially it would scan through the migrations, see what kind of schema it expects out of that. And if that schema doesn't match the one that you had, then it would basically tell you off. Get you to sort your stuff out. And this had to, a lot of the words like primary key and types and all of that sort of thing, because it had to support web SQL and IndexedDB at the same time. So a lot of the old concepts of what a schema is, I can sort of abandon in favor of something that's a bit more tuned to IndexedDB specifically. So it's we will eventually do stuff like that and sort out some migrations with a nice setup. But for now, I'm happy. I'm happy with where we're at, right? And even though this app.ts is getting a little long in the tooth, we will eventually figure this out. But I'm missing something by the looks of it. So let's find out what that something is. Okay, argument type. Sorry, I'm just going to move my mic a wee bit. Is not assignable to type of parameter of type DB. Let's see. Property of type stores are incompatible. Authors is incompatible with index signature. Oh, right, okay. I think I know what I've done. So here in field schema, gee, I've sort of messed this up. Let's move that up here. Not even further. Yeah, now let's put that one here. And let's put relationship after fields. Like that. Okay. So let me just look at this type error again, because it's going to confuse me if I try to rush it. Like type systems, like this is the thing that people hate most about type systems, and I totally understand why. But once you get used to sort of reading it, then you might like you eventually got to do it. This key. Oh, right. Yeah. So I did change the name of this key. So TypeScript is rescuing me once again. So this key, store name, store key. I'm just kidding. But, I mean, that could work, right? Yeah, that's not good. We will figure that one out. So where are we? We've got ourselves a schema. We don't do anything of it. We don't do any validation at it. But, I mean, if anyone was to look at that, they could pretty much hazard a guess as to what the structure of the application is. If I wanted to take this further, what I would do instead of building out our query functionality is probably do some sort of import-export functionality. I don't want to do that straight out of the gates next time we pick this up next Monday, however, because if we do that, that will make like 6 streams or over 6 hours doing IndexedDB, and I don't want to. Like, this is a generalist stream, so you're going to be covering a lot of different things. So we don't need a deep dive on IndexedDB yet, and there is many more things that we could be doing to build out our prototyping layer. And if we're going to bring that up, we may as well look at our to-do list, right? So we have all of that. We got that ready, and we got that ready. Good stuff. And we don't have loading transitions. We have routing. That's good. We have utilities, and they will build as they are required. So what I'm thinking is that we will go down the road of internationalization and localization when we next pick this up. And I'll talk more to that because it's a big subject. It needs to be done right from the get-go, because it makes our life a lot easier if we do end up with a success on our hands and we want to get this into the hands of people with other languages and whatnot. It already makes that process a whole lot easier. And I mean, it makes for better code structure anyway. So there's really no benefit to foregoing the concept of internationalization and localization. But we will talk more on that next time. For now, I'm going to commit my work. Now, I'm just gonna put it out there that I don't actually hate my code for database storage. There are things that we could do to make it cleaner, but I think that's going to bear out as we start to use it, where we start to see the cracks. And I think a thing to understand about the database system is we are going to be depending on it a lot. So this will not be the last time we touch this, and I'm not too concerned about leaving it just for now. Like, the moment we ship like anything to users, I'm absolutely going to be concerned about the code quality, because we cannot be making major changes to this layer once we get into once we start getting this out to people, because that's the data, like that's the thing that looks after their data that's so key and so critical, right? We'll need to have tests and all that sort of malarkey. But for now, I'm sort of happy to leave that. And what I might do is, after we do localization and internationalization, we will explore testing this system so that we can start to change it safely. Because that probably makes sense. It's like, because it's not so much the code quality that's the concern, but that we don't have tests. In my opinion, for something as critical as data, you absolutely want a good test setup. So that's probably going to be an episode real soon, like maybe not next week, but the week after. But for now, we're going to commit at this point. Okay, I think we've done our dash with IndexedDB for now. All right, setup. So this is day 14 again. So what do? We essentially set up a schema for IndexedDB databases, eventually to be used for validation and relationship getting. And it's not the greatest English, but anyway. So if we push that on its way, done, we'll add ourselves a tag for day 14. That is what this day is. We'll push that up, and that's about it. So if you, as per usual, if you want to follow along with the code at home, you'll find it at github.com/weareoffcider/weekends-webapp, and you'll see day 14 commits have just gone up. So all the code that I just did, it's right there. Help yourself. We will be picking up again next Tuesday at 8 p.m. Australian Eastern Standard Time. I mean, to be honest, I don't know if I'll ever do Fridays again, and what I'll probably try and do is either fit a later night stream on Thursdays or Saturdays or Sundays. Those are the nights I get the kids to sleep, so I have to push my time a little bit later. But I'm sort of, especially once this this is going to start getting interesting. Once we get through our localization layer, we might very well be launching into building the app itself. So there's plenty of exciting things coming up, and yeah, it'll probably be a struggle to keep to just 2 streams a week. I want to definitely do more than that. So anyway, that's our progress. Hope you enjoyed the screen. Let me fix my pronunciation. Hope you enjoyed the stream. Thanks for watching, and I'll see you next time.